This is the sixth objective for Calc BC, and we're learning our major derivative rules. Power rule, which basically we've already learned the power rule. That was in 1 the fifth objective. So if we have a variable to a power of some sort, we can bring the n out in front times u to the 1 less power times the derivative of the guts. Okay, and so this part right here, the derivative of the guts, we got to start getting used to that. So anyway, that's the power rule. That's essentially what we learned yesterday. Product rule. The product of variables. I mean, we don't really need a product rule if it's a constant times a variable, because we already know how to be able to deal with that. But if you have a product of variables, we don't have to multiply it out first to be able to do the derivative. We can do the first times the derivative of the second plus the second times the derivative of the first. So u times v prime plus v times u prime. I think it's easier to remember it in terms of words. The first times the derivative of the second plus the second times the derivative of the first. Then we have the quotient rule. Okay, the quotient rule, quotient of variables. So u over v, so v times u prime minus u times v prime over v squared. That is really hard to remember that way. So instead of that way, I think it's a lot easier to remember this way. And I didn't come up with it, but I think it's very helpful to help us remember the derivative of a quotient. Low d high minus high d low over low low. You can say something else another way. I mean, I've heard it other ways too, but it just kind of rolls off the tongue. Low d high, low times the derivative of the high minus the high times the derivative of the low over low squared. Low d high minus high d low over low low. Low d high minus high d low over low low. Low d high minus high d low over low low. And anyway, if you do that a few times, you'll have an easier time remembering that derivative for a quotient. Okay, so 3 examples. We have the rules, we just need to practice them. So y equals, now if we wanted to do this before, x squared plus 3x plus 5 times the quantity 2x minus 3, we had to multiply it out. So, but now we have a product rule for a product of variables. And so let's take advantage and let's actually do the product rule. So dy dx, the first, x squared plus 3x plus 5 times the derivative of the second. Okay, the derivative of the second, 2x minus 3. The derivative of 2x is 2, and the derivative of the second is 0. So first times the derivative of the second plus the second times the derivative of the first. The derivative of the first is 2x plus 3. Okay, now this is the derivative. We don't get to leave it like this. I mean, we still need to clean it up. And so as we're cleaning it up, I mean, we're going to distribute the 2 over here, and we're going to multiply out these 2 binomials. And so we do get 2x squared plus 6x plus 10 plus, okay, guess what? That's difference of squares over here on the right, isn't it? So we know that that's going to be 4x squared. The middle terms are going to eliminate, and then minus 9. And then if we combine like terms, we get 6x squared plus 6x plus 1. Okay, that's dy dx. Now, I know that there's probably at least one or two of you who are unsure that that is what we should be getting. So just to show that that's what we should be getting, you don't need to write this part down, but I'm going to just show it really fast. I'm going to go ahead and multiply this out. Okay, so I get 2x to the third minus 3x squared, 2x squared minus 3x squared plus 6x squared minus 9x plus 10x minus 15. Okay, and if I combine those like terms, y equals 2x to the third plus 3x squared plus x minus 15. Okay, so now if I do the derivative both sides with respect to x, I get 6x squared plus 6x plus 1, and the negative 15 becomes a 0. So, you know, it works out. Product rule works. Okay. Secondly, I guess I got to switch pages. Okay, so problem number 2. Y equals x cubed minus 3x to the fourth. Okay, now find dy dx. Well, this is really the product rule. Excuse me, not the product rule. This is really the power rule. So here is the u, so this is y equals u to the fourth. And so dy dx, so I have 4 times the u to the 1 less power. Now, times the derivative of the guts. What's the guts? The guts is the u stuff. So what's the derivative of the guts? 3x squared minus 3. That's the derivative of the guts, the derivative of the inside. Okay? And so, okay, is there any kind of cleanup that we can do? Not so much on this one. Well, there is maybe at least a GCF of 3 on the derivative of the guts. Yeah, that might be kind of nice to take advantage of. And so if I pull that GCF of 3 out, 4 times the 3 is 12. And I have x cubed minus 3x quantity to the third times x squared minus 1. Okay, and our third problem here is a quotient of variables, and we want the derivative. Okay, so here we go. dy dx is, okay, low d high minus high d low over low low. Low, so what's the low? The low is 3x plus 2 quantity squared. Low, d high, what's the derivative of the top? D high is 5. Okay, now I think it's better to put, if it's just a 5, put it out in front right there. Low, d high, minus high, 5x minus 1. D low, okay, what's the d low? Okay, well, I've got 2 times 3x plus 2 to the first times the derivative of the guts. Can't forget to do the derivative of the guts. Derivative of the guts, the derivative of the inside is 3. All over low, low. Low, low means you're going to have to square whatever it is. Okay, now we always clean things up if we can clean things up. So here we go. The numerator, let's see, there's a 5 here. Okay, we don't have anything. But there is a GCF of 3x plus 2. So GCF of 3x plus 2. Now what's left behind in the numerator? I've got 5 times 3x plus 2 minus 2 times 3 is 6. And the 3x plus 2 is already pulled out in front, but I do have 5x minus 1 all over 3x plus 2 to the 4th. Okay, now the 3x plus 2 in the numerator will reduce with one of those 3x plus 2's in the denominator. Also, when I distribute the 5, I get 15x plus 10, and when I distribute the negative 6, I get negative 30x plus 6. And so we get negative 15x plus 16 all over 3x plus 2 to the 3rd. Okay? And it really doesn't simplify any more than that. That is dy dx. So go do the assignment now.